Alright, so today's lesson is going to be on phase shift. Or phase shifts. And first we'll just look at sine and cosine. The general formula of a sine or cosine function that we've done so far is like this: y equals a sine of omega x. Alright, but what if I was to take and subtract or add some angle measure or some number from that? Alright, let's call that phi. Alright, that's a symbol for phi. Some people call it phi. Most of the time I call it phi. Then what we want to do first, if we have a trig function in this form, is to rewrite the trig function by factoring the omega out. So if you look at this problem, you may think, well, I can't factor an omega out because this variable right here doesn't have an omega. But remember, these are usually numbers. And the way that you can factor a number out if the number is not present is dividing by that number. So the way this would factor, I'd factor the omega out, and that'd leave me with x minus phi divided by omega. Alright, so the way that I factor out my omega is, of course, I take it away from this first term, but then I have to divide this second term, whatever it may be, by omega. Now, this is the formula, the general formula, if we have a phase shift. If there is a minus in front, then we're going to have a positive phase shift. So the phase shift is going to be equal to positive phi over omega. Alright. What the phase shift does is that takes the graph and shifts it over. So no longer will we always be starting at 0 when we draw a graph. So the phase shift is our new starting point for our graph. Alright. We find the period the same way. We find the amplitude the same way. We just need to figure out, where does our graph end? Where will one complete period end? So if I have a new starting point, then what could I do so that I could figure out the new ending point? Technical difficulties. Please stand by. Alright, so I have a new starting point of phi over omega. My end point, my ending point, will be equal to my starting point plus what? And the period is what? 2 pi divided by omega. So that's really how these graphs will differ. We'll have a different starting point, which then means we have a different end point. Once we have our starting point and our ending point, then we can come up with our 4 subintervals, and we'll have all of our significant points. So let's take a look at one real quick. You can see just how fun these are. It's going to be the same, the same graph that we're used to dealing with. Just going to be shifted one way or the other.